Hello, this will be your last lesson of the first part of Chapter 6. So remember, we'll be testing over 6.1 to 6.4. So this is kind of the end of a unit lesson. So just kind of keep that in mind. On that note, we will go ahead and get right to it. So this lesson is all about rational exponents. So your learning target is to kind of be able to use rational exponents and be able to, understand what those mean, and more specifically understand how those relate to what we have already learned. Okay, so here's a good diagram. Let's just see. Check the following in your calculator. So let's do that to start. 49 to the power of 1/2. Remember, you're going to use the caret key there. And then 1/2 would just be 1 divided by 2. And it says 7. And since I showed that one, I won't show the next two, but the 121 to the power of 1/2 is equal to 11. And then 125 to the power of 1/3. I know that's tough to see, but that's 5. Okay, and you can just type that in directly. So the deal is that it says if the nth root of a is a real number, m is an integer, and m over n is in lowest terms, then a to the power of 1 over n is equal to the nth root of a, right? So 7 is equal to the square root of 49. 5 is equal to the cube root of 125, in other words, okay? All right, so on that note, we'll take that little tidbit and kind of apply it to some examples. So example 1 wants us to kind of do some simplification. So A says just the 64 to the power of 1/2. I'll probably leave that one and look at these two. So what if we had 11 to the power of 1/2 times 11 to the power of 1/2? All right, so that would be equal to actually 11 times 11 to the power of 1/2. All right, or the square root of 121, which would be 11. Now, if you don't remember that, then, worst comes to worst, you just type it in. 11 to the power of 1/2 or 0.5. You can type it either way, times 11 to the power of 1/2 does give me 11, okay? So the next one would be equal to, so, you could think about it this way, or, you could also think about it this way. I'll follow this checklist. I guess I didn't really follow that checklist there. So let me do that. Let me rewrite this as the square root of 3 times the square root of 12, and then simplify. So we know that's equal to the square root of 36, and then that can be simplified, of course, to 6. Okay. The other way you could have thought of that is 3 times 12 is 36, and then 36 to the power of 1/2 would be 6, of course. Okay. All right, example 2 wants us to convert to simplest radical form. So we're going to rewrite these using a radical. Okay, all right, so what you have to know is that this says x to the power of 3 over 2, or sorry, no, 3 over 7. So what we need to know here is that this top one is your power, or your exponent, and then the denominator is the root. Okay, so this is equal to the 7th root of x cubed. Okay, so you can write it that way with the x cubed under the radical, or you can write it, as cubed is on the outside of the radical. So that does not matter. So both of those mean the same thing. I think that's kind of important to understand. So looking at the next one gives us a decimal. So this would be converting a decimal to a fraction. So x to the 0.2 is equal to x to the 1/5. And then, so that's equal to x to the first power, sorry, the 5th root of x to the first power. So just the 5th root of x. And then I'll leave c, which is w to the 5/8, and d, which is y to the 3.5 for u. Next one wants us to go the other way, right? So write an exponential form. So remember that the root is going to be the denominator of my exponent. If there's no root shown, that's understood to be a 2. So this would be equal to a to the 5/2. And then the next one says the 5th root of b cubed, right? So that would be equal to b to the power of 3/5. So kind of maybe a generalization before we move on. I'll leave C and D for you guys. Would be that if your exponent is greater than 1, then A is going to be increasing, assuming that A is greater than 1. And then if your exponent is less than 1, then that will take you the other way. All right, moving on. It gives us a nice little summary down here, which is shown in the notes, so I'm going to kind of gloss over that. Next one wants me to, it says, what is the product or quotient in simplest form? Okay, and again, sorry that this is kind of difficult to read, but this says the 4th root of x cubed over the 8th root of x squared. Okay. If these were like radicals, then we could just divide, okay? But if not, then we're gonna rewrite as fraction exponents, right? So that's the way we're gonna tackle this. So we're gonna rewrite this as x to the power of 3/4 over x to the power of 2/8. All right, which actually, 2/8 would reduce to 1/4. So I'm going to reduce that down to 1/4. And now I'm just going to apply my properties of exponents, right? Which says when I divide powers with the same base, I subtract their exponents. So that's equal to x to the 3/4 minus 1/4. Which is equal to x to the 2/4 or x to the 1/2. Right, so x to the 1/2 on that one. And I don't really know what form they're wanting. If they're wanting exponential form, that would be fine. If they're wanting simplest radical form, I guess that might be what they're wanting. That'd be the square root of x. Now, we could tackle that one that way, or, we could have reduced from the get-go. We didn't know that. I didn't tell you that. But if we reduce this down to the 4th root of x, then we have, the 4th root of x over the 4th root of x cubed over the 4th root of x. That would give us, when we divide, the 4th root of x squared, or which is the square root of x, okay, because that reduces. All right, next one, we're multiplying. So we're going to think of this in terms of exponential form. So we'd have 3 to the power of 1/2 times 3 to the power of 1/4. Now my job here is to add exponents, right? So that, because I'm multiplying, so that's 3 to the 1/2 plus 1/4. And as always, we need common denominators to be able to add there. So we're going to change 1/2 to 2/4. And then when I multiply that out, I get 3 to the power of 3/4, which which is equal to the 4th root of 3 cubed. 4th root of 3 cubed. All right, I will leave C and D for you. So C says the square root of x cubed over the cube root of x squared. And then D says the square root of 7 times the cube root of 7. All right, example 5 wants to know, what is each number in simplest radical form? Simplest radical form. All right, so let's take a look. So first of all, we're gonna want to convert this decimal to a fraction. This is 16 to the power of negative 2.5. All right, so that's going to be another way to write that would be 16 to the power of negative 5 halves. Sorry, that's kind of hard to see. 5 over 2. All right, and then when you have a negative, right, you think of the reciprocal of the base, okay? So that's equal to 1/16 to the power of 5 halves. And then we can just work it out from there. Okay, let me just show you how you could type that in, well, in one simplest radical form, I guess. So, simplest radical form. So I guess simplest radical form for this would be the second root or the square root of 1/16 to the 5th power. All right, so that would be simplest radical form for that, okay? Then you have 81 to the power of 3/4, okay? So in that one, well, I guess, sorry, I could simplify this a little further because I can take the square root of 16. So really, the simpler radical form would be 1/4 to the 5th power. I don't really know if they're this one or this one, but those are equivalent, okay? So let me actually type that into the calculator just to show you that it is. So if I did the square root of 1/16, and then I take that to the 5th power, I get that decimal, and then if I do 1/4, 0.25 to the 5th power, I get that same decimal. So you can see those are equivalent. I'm just not real sure on the form there. Then the next one, simplest radical form for this guy, we want to think of this as the 4th root of 81 to the 3rd. 4th root of 81 to the 3rd. And that may be acceptable, like if this were a Math Excel question, but then again, let's see, the 4th root of 81 would be 3. So it may want us to reduce that to 3 to the 3rd power. 3 to the 3rd power, okay? So, you know, just to show you that these are all the same, again, just focusing in on that calculator for a minute. 81 to the power of 3/4 or 0.75 is equal to 27. 3 cubed is equal to 27, and if we type it this way, it's going to be equal to 27 as well. So I'll show that one last time. So remember, to get 4th root or any higher root, you're going to go to math. Sorry, you're actually going to go, you got to type in the 4 first. So you're going to hit the index first, and then you're going to go to math, and then you're going to get the X root button. Okay, so the fourth root of 81 to the third power, also equal to 27. Okay. All right, and then we have these two at the end, a little more abstract because we have some decimals on them, or some variables in there. So the first thing we need to do is take everything in here to the power of 1/3. So this is equal to 8 to the 1/3 times x to the 15 to the 1/3. Okay, so or 8 to the 1/3. And then our exponent here would be to multiply. So 15 times 1/3 would be, that would be 15 over 3, which is 5. Okay, and then the last step would just be to simplify this. So what is 8 to the 1/3, or the cube root of 8? That would be equal to 2. So final answer there would be 2x to the 5th. All right, and then the last one. So it's always a little bit confusing on what to do with the negative there. Okay, so we'll double check at the end. All right, so we have on this one -8, and I'm going to keep that in parentheses, to the 2/3. And then we have y, the square root of y, or y to the 1/2. So I'm going to write that as y to the 1/2 to the power of 2/3. All right, so apply your exponent rule here. You get 2 over 6, or 1 over 3. Okay, so we have -8 to the 2/3 times y to the 1/3. All right, so let's punch in that -8. And parentheses are going to be important here because, that just ends up mattering. So -8 to the power of 2/3 is going to be 4, +4, right? And it's positive because, not because of the root there, but because when we square it, it becomes positive. -8 squared is +64, right? So that's how we end up with a positive there. So the signs matter. So that's equal to 4. And then this we would just write as the cube root of y. So 4 cube roots of y. All right, so that wraps up our last lesson. We will kind of transition into review mode after this. Hope this helps. Let me know if you guys have any questions.